Hello students, welcome to online classes. In our last video we have discussed about hydrogen peroxide preparations, physical, chemical properties. In this session I am going to discuss about one important topic in objective point of view, that is volume strength of H2O2. So volume strength of H2. The strength of H2O2 is represented in terms of volume strength. The strength of H2O2 represented in or expressed in terms of volume strength. Strength of solution means weight of solute in 1 liter of solution, that is called strength of solute. Weight of solute in 1 liter solution is called strength of solution. Now, so volume strength definition. Volume strength of H2O2 on decomposition gives H2O and O. The amount of oxygen released when V volume of H2O2 decomposed, called volume strength. Amount of O2 released when V volume of H2O2 decomposed, called volume strength. Amount of O2 released by V volume of H2O2 called which one? Volume strength. Now, so it can be written as 2H2O2 equals to 2H2O plus, right? Amount of oxygen gas released by V volume of H2O2 called which one? Volume strength of H2O. For example, H2O2 marketized as 10 volumes of H2O2. Next, 20 volumes of H2O2, 30 volumes of H2O2, like that. What is meant by 10 volumes of H2O2? 10 volumes of H2O2 means, it means 1 volume of H2O2 gives 10 volumes of oxygen. 1 volume of H2O2 gives 10 volumes of oxygen gas. Clear it is? This 10 indicates oxygen gas released. Otherwise, 1 milliliter of H2O2 gives 10 milliliters of O2 gas. Clear? Similarly, 1 liter of H2O2 gives 10 liters of oxygen gas. Understood? 10 volumes of H2O2 means 1 volume of hydrogen peroxide gives 10 volumes of oxygen. For example, 30 volumes of H2O2 means 30 volumes of H2O2 means 1 volume of H2O2 gives then 30 volumes of oxygen gas. Clear it is? 1 volume of hydrogen peroxide gives 30 volumes of oxygen, that is called 30 volume H2O, 30 H2O. Otherwise, if volume taken in milliliters, 1 volume of H2O2 gives 30 milliliters of oxygen gas. Similarly, if you take in liters, 1 liter of H2O2 gives 30 liters of what is that? Oxygen gas. This is the meaning of which one? Volume strength. Now, I will consider 10 volumes of H2. Volumes of H2. Right. Right. Consider 10 volumes of H2. What is the meaning? 1 ml of H2O2 gives 10 ml of oxygen gas. This is the meaning of 10 volumes of H2O. Now, 2 H2O2 gives rise to 2 H2O plus gas. This is the balanced equation. So now, hydrogen, 2 hydrogens, 2 16s, 32, totally 34 grams, 34 into 2. 2 into 34 grams of H2O2 liberates. It is 1 mole of any gas can occupy 22.4 liters, otherwise 2 to 400 milliliters of oxygen gases. Now, if I took 10 volumes of H2O2, how much oxygen gas will be released? 10 milliliters. For 10 milliliters, that is a 10 volume of which one H2O2 gives or required how many grams? Then 10 into 68 by what is that? 20 to 400 milliliters. If you solve this, you will get 0.03035 grams of H2O2 required. Clear it is? It means 1 ml of H2O2, 1 ml of 10 volume H2O2 contains this many grams of H2O2. Clear? It means 1 ml of 10 volume H2O2, 10 volume H2, 1 ml of 10 volume H2O2 means 10 ml of 10 volume of H2O2 contains how many grams of H2O2? 0.03035 grams of H2. Clear all of you? If I took in percentage, I need for how many milliliters? 100 milliliters. If I took 100 milliliters, how much is? Then you get 100 into 0.03035. That is equal to 3.035 grams. This is for 100 milliliters. Then for 100 milliliters of 10 volume H2 contains grams of H2. Right now? So 100 milliliters means I can make it as percentage. Clear all of you? So what is the percentage of H2O2 present in 10 volumes of H2? 10 volumes of H2O2 is equal to 3.035% of H2. Otherwise, grams. Otherwise, right? It is for percentage. Only 1 ml contains this many grams. 100 ml contains this many grams. 100 ml means percentage. Now, strength of your solution is strength of solution is weight of solute in volume of solution that is equal to 1 liter. Remember, the weight of solute present in 1 liter of a solution called strength of a which one? Solution. Strength of 10 volume H2O2 is equal to weight of solute in how many liters? That is 1000 liters. 1 ml of 10 volume H2O2 contains how many grams? That is 1 ml of 10 volume H2O2 contains 0.03035 grams. 1 liter means how many? 1000 ml of 10 volume H2O2 contains how many grams? 1000 grams. For 1, 0.03. For 100, how many? 3.03. For 1000, that is equal to 30.35 grams. It is strength of, what is that? 10 volume H2O2 solution. What is the meaning of 30.35 grams? 30.35 grams of H2O2 present in 1 liter of H2O2 solution. Clear our meaning? It is the strength. So I will write in a box out from this. Next, molarity we will calculate now. Molarity for 10 volume of H2. Molarity for 10 volumes of H2. 10 volumes of H2O2 considered. Generally, molarity formula is mass by gram molecular mass into 1 by volume of solution in liters. It is the formula. So, liter means 1000. Then, weight of H2O2 is equal to, in 1 liter, what is the weight here? 30.35 grams of H2O2 in 1 liter. It is nothing but 1000 ml of H2O2 solution. Clear this point, all of you? Right? Then weight, gram molecular weight of H2O2 is equal to, you know the gram molecular weight, that is equal to H2O2. What is the mass here? 16 plus 16, 32 plus 1 plus 1, 34. Totally 34 grams. Volume of H2O2 solution. H2O2 solution. It is equal to 1 liter, that is equal to 1000. Substitute all values, then you get molarity, weight 30.35 grams by gram molecular weight 34 grams into 1 by 1. So on solving, so you get here 0.8, the value will be 8926 molar. It means moles per liter. 0.8926 moles per liter. This is the molarity of 10 volume H2. You know the relation between the normality and molarity. You can find the normality also. Normality equal to 2 into molarity. Clear it is? Then normality equal to 2 into 0.8926. Then it is 1.7. The value will be 785 normalities. It is also called 1.785 gram equivalents per liter. These are the units of normality. Moles per liters, molarity units. And you have to remember always, so few points, very, very important. Now the first one is molarity of 10 volume H2O2. It is equal to 0.8926 molar. Normality normality of 10 volume H2O2 solution is equal to 1.785 right? Similarly, strength of H2O2, that is 10 volume H2O2, it is equal to totally how much it is 30.35. Clear all of you? Grams per liter. So strength of 10 volume H2O2. Percentage of 10 volume H2O2 equal to, what is the percentage of H2O2 present in 10 volume of H2O2? It is equal to 3.035 percentage. Percentage means in 100 milliliters. Clear all of you? You have to remember these values clearly and it helps you a lot. Now the problem is, I have considered 10 volumes and we have calculated the molarity, normality, volume strength, and volume strength equal to 10 mol. Molarity equal to 0.8. Normality for 10 volumes H2O2 equal to 1.7. And strength of 10 volume H2O2 equal to 30. And percentage of 10 volume H2O2 equal to 3.035. This, there is no problem at all. If they give 20 volumes, if they give 30 volumes, 100 volumes, in that case you have to follow the total procedure and you need to find the which one molarity, whatever the term they will ask. It is a lengthy process and difficult process. To overcome that, I will give a generalized formula to find the volume strength, molarity and normality. We will see that. So general formula to find the volume strength. To find general formula. So how to follow? Says 2H2O2 gives rise to 2H2O plus. This is the decomposition reaction of H2O. 2 into 34 grams of H2O2. It gives 1 mole of O2. 1 mole of any gas occupies 22.4 liters of oxygen gas. They gave volume strength. If 10 volumes, that is 10 milliliters of water. If 30 volumes, 30 milliliters of O2 will be generated by the 1 volume of H2O. V volume means V liters of which one, that is V liters. If I took liters, both must be in liters. If I took milliliters, both must be in milliliters. V liters of oxygen liberated by how many units? It means mass of H2O2. Mass of which one it is? Tell me all of you. V volume of H2. 10 volume means 10 liters. V volume means taken as a V volume of H2O2. It is equal to V into 68 by 22.4 grams. Clear all of you? This is the mass, nothing but weight. Next, after this, gram molecular weight of H2O2, it is equal to 34 grams. Already we know. So, molarity formula, weight by gram molecular weight into 1 by volume in liters. Clear? Number of moles per 1 liter solution is called as molarity. Then volume is considered as 1 liter of H2O. Substitute all these terms. Molarity equal, what is weight here? Volume into 68 by 22.4. This is the weight. Clear all of you? By gram molecular weight equal to how much? 34. Weight by gram molecular weight into volume 1 liter is. Clear all of you? Then on solving this, V into 68 by 22.4 into what is that? 34. On solving you will get totally V by 11.2. This is equal to molarity. Very, very important, very simple, and no need to confuse you. Molarity equal to V by 11 point, where M equal to molarity of V volume of H2O2, clear all of you, and V equal to volume strength of H2O2, understood? Next, if you well know, easy to find. Now example, first example. 10 volumes if I consider, 10 volumes of H2O. Calculate the molarity of 10 volumes of H2O. They will ask me question. So, molarity equal to V by 11 point. V means 10 by 11 point. Molarity equal to 0. So, 8926. I calculated this lengthy method, that is, but by a simple formula you can. No need to by heart this derivation, only formula you can. Okay? And molarity of 20 volumes, 30 volumes, you can find very easily for all, clear all of you. Next, if they give volume strength, you can find the molarity. If they give molarity, you can find the which one? Volume strength. Easy. Normality equal to 2 into molarity. So, molarity equal to N by 2. So, this is 1, this is 2. Substitute 2 in 1. Clear all of you? Then, molarity place is replaced by normality by 2. Volume by 11. Will be how many times? 5.6 times. Then, normality equal to V by 5.6. It means volume strength given, then you can find which is that normality. For example, 10 volumes of H2O2 normality if you calculate. Normality equal to 10 by what is that? 5.6. So it is 1.75 etc. Right now all of you. So simple formulas you have to remember. Molarity equal to volume strength by 11.2. Normality equal to volume strength by 5.6. With this you can easily find. I'll give you one simple example. Bits also given in the previous exams. So this all by these two formulas. So I'd like to take 30% or 30 volumes. Find the percentage of H2O2, molarity of H2O2, normality of N indicates normality of H2O2 in 30 volumes of H2O. This is the question. I gave you 3 questions. So simply they will give you only one question in the examination. So now, how to find answer for this? Now percents, 30 volumes. 30 volume of H2O2 meaning is, what is that? 1 ml of H2O2 gives 30 ml of oxygen gas. Clear all of it? So as you know that 10 volumes of H2O2 equal to 10 volumes of H2O2, percentage already calculated. How much percentage that is? 3.03%. I need for 100 volumes of H2O2 equal to 30.35%. Very, very important. Last case I gave 30.35 grams per liter. That is a strength of a solution. Here, what is that percentage? Comparatively, I will write afterwards. Then next, 100 volumes, 30%. So, 30 volumes no for us. here, which okay, 30 volumes of H2O2 will be 9.09 percentage. Percentage means 9.09 grams of H2O2 per, what is that, 100. Clear all of you? Strength means 1 liter. How many liters? 1 liter. Next, molarity. Molarity equal to volume by 11.2. What is the volume strength given in the problem? 30. 30 by 11.2. Then you get answer. Okay? So 30 by 11.2. 2.67 molar. Normality equal to, there is a formula, that is volume strength by 5.6. 30 by 5.6. You get the answer clearly. Normal, gram, equivalent, clear color. So you can easily find 100 volumes if I took for 100 volumes. 100 volume of H2O2 equal to how much percentage of H2O2? So this is tricky and very, very important. 100 volumes. 10 volumes of H2O2 equal to, you have to remember this, 3.03%. 100 volumes of H2O2 equal to how much percentage? 100 into this one. Totally 10 times. The answer will be 30.3%. It means 30% of H2O2, it is equal to 100 volumes of H2O2. This is called perhydrol. What is that? Perhydrol. Important, already given this bit in the previous explanations, right? So with this volume strength completed, so we'll discuss one or two simple problems on this topic. Now, calculate the volume strength of 4 normal H2O. Calculate the volume strength of 4 normal H2O. Clear? It is the solution. So normality and volume strength relation will be normality equal volume strength by 5.6. Normality how much given here? Volume strength equal to normality into 5.6. 4 into 5.6. Right? Then you get answer here. The answer is 22.4. 22.4 V. What is the meaning? 1 milliliter of H2O2 gives 22.4 milliliters of oxygen gas. This is very, very important. Many problems are there. We'll discuss afterwards. And the next topic in this chapter is, the last topic is, so that is the structure of H2O2 in gas phase, liquid phase as well as solid phase. Okay, students, structure of hydrogen peroxide in a gas phase as well as solid phase. It is a open book structure. Open book structure. Here, oxygen, O2, hydrogen, H2O2 total. OO bond length will be 147.5. OH bond length will be 95. And OHOO, this angle will be 94.8. And this angle will be 11.5. It is a dihedral angle. And now here also, this angle will be 90.2. OH bond length will be 98.8. And this will be 101.9. The length will be 145.8 picometers. You have to remember this chance to ask these parameters also. Next, afterwards, storage of H2. How to store H2O2. Generally when exposed to air it will be decomposed. When H2O2 exposed to air, it will be decomposed into H2O and O2. Clear? Already reaction written. 2H2O2 is raised to 2H2O plus oxygen gas. It means we cannot store in presence of air. It should be stored in the dark room. If you store this in metal bottles or glass bottles, those materials act as a catalyst, and this reaction will be happen in presence of metal bottles or glass bottles. So H2O2 should not be stored in glass or metal surfaces or metal bottles, because glass or metal catalyzes the above reaction. It means it will be happen on its own. If metal or glass bottle is there, those act as catalysts and the reaction will be speed up. We cannot store H2O2 even 2-3 minutes also, because the reaction will be speed up, decomposition. That's why, so H2O2 stored in wax lined glass or plastic bottles to prevent the decomposition. Bottles in dark room in absence of air, otherwise it will be decomposed, right? This is the storage of hydrogen peroxide. Urea is added as stabilizer. It means to make it stable, urea is a chemical added. Finally, uses of H2O2, especially I am not writing. H2O2 act as which one? Antiseptic. Next, disinfectant, mild disinfectant in high concentration level, antiseptic in low concentration level. It is used to prepare many chemicals like used as a bleaching agent, nothing but a cleaning agent. So used as antiseptic for cuts and wounds. So it is used to prepare many drugs also. These are all uses of H2O2 hydrogen peroxide. Next is heavy water. Heavy water is called deuterium oxide. Deuterium oxide is called heavy water. The formula is D2O. D2O. It is called heavy water. So the name is deuterium oxide. Deuterium oxide. Clear it is? Preparation. Generally it is prepared from water only. So here 1 ml of D2O is obtained by 1 ml of deuterium oxide is obtained by electrolysis of 30 liters of water in alkali. Alkali means we have to add a little amount of a base to act as a medium. Then it means this content is very, very less. So we can prepare in the laboratory by electrolysis method, because it is in a ppm level, parts per million levels. Physical and chemical properties. properties especially. So the D2O properties are properties, especially physical properties, already given in the second video. You can follow. Little greater than that of H2, little variation because of the mass. And chemical properties, the all properties given by water can show D2O also, but occurs slowly because of its mass. Hydrogen 1, deuterium 2. It means all the reactions which are given by the water can also exhibited by the deuterium oxide, but it will be very slow. Few reactions in this. Calcium carbide treated with D2O, then gives us then C2D2, actually C2H2 if you take water, then gives us CaOD twice, take 2 times. C2H2 means acetyl. Deuterium is there, deuteroacetyl. It is called deuteroacetyl. So very important. Next, SO3 plus D2O. SO3 plus H2O is H2SO4, and here D2SO. Deutero sulfuric acid. They are only sulfuric acid. If you take H2SO4. It is a deuterosulfuric acid. Al4C3 plus 12D2O. 12H2O if you take, stage 4 will be formed. 3CD4. Actually if you take H2O, CH4 will be formed. Then 4 moles of, if you take H3O, H2O, AlOH thrice. I am taking D2O, that's why OD thrice. Actually, CH4 is a methane, it is a deuterium, that's why called deuteromethane. Deuteromethane. Clear? And few uses of heavy water. Uses of heavy water. So it is used as tracer compound. To find mechanism especially. It means to know the mechanism experimentally one compound is required, that is called as a tracer compound, especially for aromatic, electrophilic substitution reactions. How the reaction will be happened for this? So that should be traced by the compound called which one, and deuterium hydroxide, deuterium oxide. Next, used as moderator in nuclear reactors to slow down the neutron's speed. We are using which one? Deuterium oxide as which one? Moderator. Next one. Used as germicide. And bactericide. Germ means germs. Cidal means killing effect. The drug which is used to kill the germs or bacteria called germicidal properties or bactericidal properties. Right? With this, and next one is the last topic is hydrogen gas as fuel. Hydrogen gas is a component of CNG, compressed natural gas, and LPG, liquid petroleum gas, other fuels, hydrocarbons only. So what is the percentage of dihydrogen and what is the energy liberated in all those fuels? We will observe once tabular form. Okay, hydrogen gas used as a fuel. It means hydrogen, other hydrogen components can be used as a fuel, and the energy released by this fuel on combustion of these fuels I have written per mole, kilojoule per mole, kilojoule per gram, kilojoule per liters. So for example, dihydrogen gas. So if it burns, hydrogen gas can also use as a fuel. 5% of H2O2 plus compressed natural gas used as a fuel in automobiles nowadays. So now, 286 kilojoules per mole of energy will be released by the dihydrogen on the combustion. Similarly, many more given. LPG, if you take 2220 kilojoules per mole of energy will be released on the combustion of which one, that is LPG gas. Similarly, 25590 kilojoules per liter of energy will be released by the combustion of which one, LPG gas. Similarly, 344005 kilojoules per liter of energy will be liberated by the combustion of octane gas in a liquid state. Just compare these values, which is having higher, which is having lower. You have to remember that only. No need to by heart these values. Clear all of you? So with this, the synopsis for the hydrogen chapter completed. So you have to focus on few topics. First one is volume strength of hydrogen peroxide and problems. Second one, oxidizing and reducing properties of H2O2, hydrogen peroxide. Third one, hardness of water. It means what are the methods and what are the chemicals used to remove the temporary and permanent hardness. That is important. Degree of hardness, right? Water and its reactions. Okay. So in our next video, we start bits.